Hi, 8th grade. Welcome to lesson 4.3. Use linear models to make predictions. By the end of the lesson, I want you to be able to say, I can make a prediction by using the equation of a line that closely fits a set of data. Let's solve and discuss it. Bao has a new tracking device that he wears when he exercises. It sends data to his computer. How can Bao determine how long he should exercise each day if he wants to burn 5,000 calories per week? Pause the video, write down a time in minutes, and we will press play when we're ready. Okay, so the first thing I would do is draw a trend line. So remember, trend line goes through the middle of most of the data. He wants to burn 5,000 calories per week. Well, we don't have 5,000 on this list, but there are multiple things we can do. We can find his unit rate. So we can pick a good point and find the slope. So I can see that, let's see, on our trend line, here's a good point right here. He burns 200 calories in 25 minutes. If we divide, we can find out how many calories he burns in 1 minute. So 200 divided by 25 is 8 calories, and I divided by 25. Whatever you do to the bottom, you got to do the top. But we want to know how long it's going to take him to burn 5,000 calories. So I'm going to do 5,000 divided by 8 to know that to get from 8 to 5,000, we have to multiply by 625. So if you do the bottom, you do the top. So it's going to take him 625 minutes to burn 5,000 calories. Another way you could have done this is seen that 500 calories gets burnt in 50 minutes. So there's 500 calories in 50 minutes. 55 minutes. We want to get to 5,000 calories. So all you got to do is multiply by 10. So that would give us 550 minutes. Now, 625 is not the same thing as 550, but they're close to each other. We're just doing an estimation. Focus on math practices. Suppose another set of data were plotted with a trend line passing through 2500 and 8550. Would this indicate that more or fewer calories were burned per minute? Burned per minute, that tells me that we got to do the slope again. Well, remember, slope is y2 minus y1 over x2 minus x1. So here we can label x1, y1, x2, y2. So you do 550 minus 100 divided by 80 minus 25. 550 minus 100 is 450. 80 minus 25 is 55. So we do 450 divided by 55. That gives me 8.18. So I would say that about the same amount of calories were burned per minute. So the same, because they have the same slope. Same slope or rate of change. Example 1. Use the slope to make a prediction. Michaela is a speed skater and hopes to compete in future Olympic Games. She researched the winning times of the past 50 years. If the trend in faster speeds continues at the same rate, how can she use the information to predict what might be the time to beat in 2026? So the first thing we have to do is write an equation for this trend line. Remember equations, y equals mx plus b. So we have to find both the y-intercept, that's the b, remember we begin with the b, and m, the slope. So they look for the y-intercept, it crosses at about 2.4. So that's why they have 2.4 for the b. The next thing they do is find the rise over run. So they pick 2 points, they saw that it went down 0.2 and ran 15. So they divided that to get the slope. So there's the equation of the line. Now she wants to know the time in 2026. So if the x value is years after 1960, we need to know how many years has it been if we're in 2026. So we're going to do 2026 minus 1960. That gives us 66 years. That's why they put 66 in for the x. Follow PEMDAS, they multiplied first and then added to find that the winning time would be 1.5222 minutes, or about 1 minute and 30 seconds. Let's try it. Assuming the trend line shown in the graph continues, use the equation of the trend line to predict the average fuel consumption in miles per gallon in 2025. So we are trying to find the M and the B first. Well, the B is right here. That's between 12 and 18. So that is 15. So our B value is 15. Now we have to find the slope. So I'm going to pick 2 good points. Now I need to count. My slope is my rise over run. So I go up 1 over 2, but please remember, it's not just up 1. It might be up 1 box. We need to know how much each box counts for. We already found that each box counts for 3. So it's going to go up 3. And looking at the bottom, each box goes over by 5s. So it goes over 2, so that's over 10. So our rise is 3, our run is 10, meaning our slope is 0.3. 3 divided by 10 gives us 0.3. If we were trying to find the miles per gallon in 2025, and x is the years after 1980, we need to subtract 2025 minus 1980. Subtract, that's 5. We got to do some borrowing. 8, 9, 10, 11, 12. So that's 45 years. So we're going to plug that 45 into our equation. Y equals 0.3 times 45 plus 15. PEMDAS tells me to multiply first. So 45 times 0.3 is 13.5 plus 15. Y equals 28.5. So the average fuel consumption is about to be 28.5 miles per gallon. Why can you use a linear model to predict the y value for a given x value? Is because you can substitute and solve. All right, example number 2. Use a scatter plot to make a prediction. A scatter plot shows the relationship between the number of people at a water park and the temperature. About how many people should the owners of the park expect the water park when the outside temperature is 90 degrees? Well, all you got to do is look down here at temperature, find 90 degrees, follow it up to the trend line, follow it over to the number of people. So the park owners should expect about 800 people. Example 3. Interpret the slope and y-intercept. The scatter plot at the right shows a linear relationship between the temperature and the number of smoothies purchased in thousands. What does the rate of change or the slope represent in this situation? So the rate of change or slope describes the number of smoothies purchased for each degree of temperature increase. All we're looking at is, can we interpret the y and x values? Well, we know that slope is always rise over run. So our rise is smoothies, so it's 3 smoothies for every 5 degrees. What does the y-intercept at the line represent in this situation? Well, the y-intercept is when it is 0 degrees. So the y-intercept represents the number of smoothies sold when the temperature is 0 degrees. What equation relates the temperature x and the number of people who buy the smoothie y? So first they find the slope, they pick 2 points, 40, 32, so that's right there, and 80, 56, and you can see up here, that's when they did the slope equation. So that goes here, 3/5 x, and our starting was at 8. A smoothie cafe has ingredients to make 50,000 smoothies. on a day when the high temperature is expected to reach 90 degrees Fahrenheit. Should the cafe employees expect to have enough ingredients for the day's smoothie sales? Explain. So we can use the equation y equals 3/5 x plus 8. And we know the temperature is supposed to be 90. So we're going to plug 90 in for x because that's temperature was on the x-axis. So 3/5 times 90 plus 8. So I'm going to do 90 times 0.6 because that's what 3 divided by 6 is. Or sorry, 3 divided by 5. So that's 54 plus 8, which equals 62. And remember, the y value was in thousands. So that means they should expect 62,000 people wanting smoothies. They only have the ingredients to make 50,000 smoothies. So will they have enough? No. They need 12,000 more smoothie ingredients. Key concept: scatter plots can be used to make predictions about current or future trends. Look at the corresponding y value for a given x value. So any x value can follow it up to the trend line, follow it over to see what y value matches. And you can also find the equation of the trend line by finding the y-intercept and finding the slope. All right, 8th grade, let's say it. I can make a prediction by using the equation of a line that closely fits a set of data. Have a great day.